Okay, what we have here is the 11 notes on least common multiple. Now, multiples you've done before, you may not remember you've done them, but you have done them before. And what we've done before, a multiple is, for example, the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, etc. If you look at the multiples of, let's say, 5, those would be 5, 10, 15, 20, 25, 30, and so on. When we talk about a common multiple, we're looking for one that they both have in common. So you can see here with the 3 and the 5, they share a multiple of 15. Now, they share a lot of other multiples. 30 would be one that 3 and 5 can both divide into. 45, 60, there's a lot of different ones. But when we talk about the least common multiple, we're looking for the smallest of the common multiples. So here we have some numbers, and there's definitely ways that you can do this in your head. You've done this before with least common denominator. Okay, but I'm just going to show you a way to do it, and that's just because when I change the idea and make it harder, I want to show you it's the same thing. So what I looked at here is I said the factors of 3 are 3, the factors of 6 are 3 times 2. What's one they share? Okay, if they share it, you're only going to bring that down one time. And then you're going to bring down everything else. So 6 is the least common multiple of 3 and 6. It's the smallest number that 3 and 6 can go into. And I did the same idea here. I broke them up into their factors. If they shared a factor, I only brought down one of those. And then I brought down everything else. Okay, so 3 times 2 times 5 is 30. In this example, and 30 is the smallest number that 6 and 15 can go into. Again, there are a lot of different numbers that 6 and 15 can divide into. We want the smallest of those. Here I have 7 and 5. They didn't have any common factor, so I just brought both of them down. So 35 is the smallest number that 7 and 5 can go into. And when I did 4 and 30, I had one set of 2's that matched, and then I brought down all the rest. Okay, so using that idea again, that this number, your final least common multiple, should be a number that 4 can divide into evenly and 30 can divide into evenly. It's the smallest of the numbers that can happen. What I'd like you to do right now is a very similar idea here. I would like you, sorry about that, is to do that with the x's. Look at the factors, just like we did before, and I think you're very quickly going to realize a pattern. So push pause now and try that. Okay, when you come back, again, you'll see I did the same idea. Every time there was a common factor, I brought one of those down. So that's here, here, and here. And then I had 2 more extras I brought down. So I got x to the 5th. And you should see very quickly that when finding the LCM of 2 variables with the same base, use the one with the larger exponent. So it's actually the opposite of like GCF. So there's the answers there. So now we're going to find the least common multiple of these different terms, or I'm sorry, these different expressions. So what I'd like you to do is give these a try. Just give them a try. Go to all your factors. Take the different parts. What's going to multiply to give you 12a squared b to the 5th? What's going to multiply to give you 18a cubed bc? Okay, so give these a try and then come back and we'll talk about the answers. All right, so here I did the work. Again, 2, 2, and 3 are the prime factors of 12. So I had a common factor of 2 and a common factor of 3. So that one goes here. Oh, here's another 2 over here. That's where that one came from. I have an extra 3 and a common 3. So all of those are brought down. I did the same with the a's. Notice I had, but you can even look at that with what we just did before. I have a squared and a cubed. So what's the least common multiple of a squared and a cubed? The smallest that both can go into, a cubed. B to the 5th and b. There you go. And then this one, remember, we brought the extras down, anything extra down. So the c is included here. For these, again, the common 2, I brought that down. and then I have the extra 2 and the extra 3, and then the x to the 5th. The 9x to the 4th, again, here are the primes, 6x and x plus 5 to the 3rd. I wrote everything that multiplies to be that. So they have the common 3. That was brought down here. Here's a 3. Got to bring that down. Here's a 2. Have to bring that down. Bring down the x's, x to the 4th, and all the x plus 5s. So this is your final answer. Over here, I did the exact same thing. What multiplies? I had 2 common 2's. Okay, so that's where these came from. I had the x from up here. That's where the x came from. And I had this a minus x. So this is your final answer. All right, we're going to work the same way here. Now with these, with the addition and subtraction, remember that those are in like parentheses. So remember, we're looking for what multiplies to be those. So we're not going to go 2 times a minus 2 times b. Do not do that with addition and subtraction. Look for a GCF just like we did before. Okay? And try it that way. Over here, again, see the addition and subtraction. Okay, I don't want you to start, you got to figure out what multiplies to be the expression j squared minus 9, and hopefully you'll say j plus 3, j minus 3. Over here, what multiplies to give you that? Okay, first look for a GCF. Oh, there's a GCF there of j. Factor that out and try again. So give these a try again, and then I'm going to go through the answers. All right, in the next slide, you'll see I have the 2 times a minus x, 3 times a plus x. There were no matches here, so I'm going to bring down the 2, the 3, the a minus x, and the a plus x, which gives me an LCM of this. Over here, I factored out the 2. That's where this came from. I factored out a 4, greatest common factor of 4. That's where the 2 times 2, I broke up the 4. So I had a common 2. That was down. This is down, and they both had a common a minus b, so I brought that down. So my least common multiple was 4 times a minus b. J squared minus 9 factored into j plus 3j minus 3. J squared plus 3j factored into j plus 3. So I brought down the j. I had common j plus 3's, bring that down, and the j minus 3. So this whole thing is the LCM. X minus y quantity squared just means it's multiplied by itself. X squared minus y squared factors into x minus y, x plus y. Well, they have a common x minus y, another x minus y, and an x plus y. So this is the least common multiple of those two expressions. All right, on our final turn, we're going to do the same idea. So once again, looking at the factors, what factors they have in common. So I would, again, like you to try these. Do your best. At least try, because then if you make a mistake, you'll be able to recognize you made a mistake. So start with the factors and do your best. All right, over here I have the answers. Now here I kind of wrote all this out in a big long thing, but you can also look at it this way. Look at this one. This one has some x minus 2's. Does that one have x minus 2's? Nope. So we're going to need all of those x minus 2's. Here I have x plus 3. I have 2 of them. Here I have 3. They both have x plus 3's. I take the higher one. So that's where this one came from. And then this one has an x plus 2. They didn't share that, so I have to take all of those. Over here, you can work the same idea. I have an x minus 3. This expression doesn't share that, so the x minus 3 has to come. They share an x plus 2, so I only need to bring one of those, and then I need to bring the x minus 7. In the bottom two, I factored this expression into x minus 5, x plus 3. I factored this expression into x minus 5, x plus 1. They have a common x minus 5, and I bring down everything else. But notice that I looked at the factors. I didn't write x minus 2 times x minus 3 times x. No, 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 no. It's what are the two factors that multiply to this expression. And over here I did the same thing. I factored this trinomial. I factored this trinomial. They shared the x minus 1. Bring down the rest. And that concludes 11.4, which is necessary as we get to 11.5.